Merle here, welcome back to Prairie Wings. In this video, what we're going to be doing is we're going to be taking the cam sensor and the crank sensor that we have built in previous videos, and we're going to be getting them timed mechanically, and then we're going to be entering the information into the ECU properly so that this engine and the ECU can work together. The ECU actually knows what those sensors are supposed to be saying. So check it out as we go through that process. First of all, if you take a look, the crank sensor there, it is a 36 minus 1 crank sensor. And right now where it's sitting is the sensor is actually on the missing tooth. And then the cam sensor, well, we made that as a single tooth cam sensor. And what we've done is I actually used a engine stop to get the exact correct timing marks. And they are within a degree. They're hard to see down in there, but there's the timing marks. And you can see the notch is very close to 0, but it is within a degree. And that may be changed after the engine is rebuilt because the balancer is kind of separating on this. We'll probably be putting a new balancer on it. Now, what we've done is we have this at number 1 top dead center. And how we did that is rotate the engine and put a finger in the plug hole while we're turning it over. We can feel compression coming up as this turns around. All right, I am just going to take a look at the firing order here. 1, 4, 5, 2, 3, 6. And then the original cap off of this, if you don't know which direction the engine turns, you can tell by the timing marks on them, but if you don't know, you can actually look when this was taken apart. This is cylinder number 1, 4. Okay, so if we look at the firing order, we know that this engine is turning in this direction. So we know that this cam sensor should be turning in this direction, which on a Corvair is actually loosening the crankshaft bolt, which if it's torqued properly, it won't loosen by turning it over. But that is where we are so far. So timing marks confirmed to be within a degree. We have the cam and crank in the number 1 top dead center position with the crank sensor sitting in that open gap. There are very good instructions in the Megasquirt for this setup, and it's a common setup. And I'm just going to do this. I'll explain it to you so we're not reading it out of the book. I can set it up quite easily. And the reason that I chose this, well, I'm going to go over that with you. On a Corvair, from what I understand, I am no Corvair expert, and please chime in on this, but from what I understand is the cylinders in this thing don't fuel very evenly the way it was designed. So the whole goal of this is to have fully sequential fuel injection. This car will be a touring car. It's going to get miles on it. And because it's air-cooled, we run it a little bit richer. So we have a couple things that we're going to be doing to combat that, first of all. And one of them is by fueling the engine more evenly. And the other one is we'll be adding water methanol injection to actually clean any of the carbon that might be built up in this. So this should be a long-lasting, good running. I'd say I'm going to try and make it run a little bit leaner than normal air-cooled. We'll see what temperatures and stuff do. We'll see how it does on the dyno. I am probably talking terminology that some people may not understand, and I need to back up a little bit. We have with this fuel injection, where we have the injectors in each cylinder, we could be running what's called batch fire or sequential. Batch fire is 3 of the injectors fire on 1 turn and 3 of the injectors fire the opposite turn. So doing that, we're kind of, I mean, we could have bought the throttle body units and put on and done kind of the same thing. But what we're wanting to do is get this fueled very evenly. So with sequential fuel injection, what happens is because we have the cam sensor, it knows exactly what stroke we're on so that we can fire this injector at the back of an intake valve just before it opens, so we get great atomization. And as soon as the valve opens, we have atomized fuel going into that cylinder. As well, with the setup, we can use the coil on or near plug individual coils for each cylinder by going with this fully sequential fuel injection. So hopefully that's going to help some of the issues that these may or may not have had. I am going off of information that I have researched for this. I am, again, like I say, no expert, but I do know how to make sequential fuel injection. So instead of me blabbering, let's go into how we are going to set this up mechanically. So very first of all, our main sensor you can see is our crankshaft sensor. Secondary is a camshaft sensor. So we have to identify our number one tooth, and that is on the car, the rotations backwards. It would be the tooth that comes up to the crank sensor next after that missing tooth. If this wasn't a missing tooth, it would be, I believe, I'd have to read, but I believe it is the next tooth after this is passed by. Don't quote me on that. It'll be in the manual. I'm not reading it. But main point is you need to identify which is the number one tooth, and it's quite difficult to see on the car because of where it is with the camera, but it is going to be the tooth on this side because this is coming up. So the tooth on this side of the gap is number one. All right, I have rotated the crankshaft now in the opposite direction of normal travel until I hit the number one. So it's almost a full rotation to where I am on that number one tooth. And you can see the cam sensor is now facing a long ways away. And what it is, it's actually 12 degrees off. So we take 360 minus 12 to the rising edge, because that's what we're going to set it at. And we have 348 degrees, and that is going to be our crank sensor setting in the ECU. All right, during setting up the ECU, I have the ECU fired up with the key on, but I have the fuel pump relay taken out so that my fuel pump isn't running, especially because this doesn't have fuel in the tank. But even though the ECU only charges the system with this, every time I key cycle it, I don't want that dry fuel pump running. And then we are connected to the laptop, and the laptop definitely isn't set up. The screen isn't how I'm going to do it as I'm going, but what I want to get into is just these ignition settings. So I go up into the ignition, and I'm going to go into the wheel decoder. So in here, I have already set all this up, but we are going to, with this configuration, a toothed wheel. We are going to be using rising edge for both of the cam and crank sensors. Now, this spark output, almost everything uses going high. Coil on plug is a selection we used. Hardware is spark. Our input for the cam is a cam sensor. We are using dual wheel with a missing tooth. That crank sensor has 35 teeth, but we call it a 36 minus 1. I've written in the 348 in there, and the main wheel is that crank wheel. And then we have the second one. We are going to use rising edge. Now, we're going to be using the table up in here, and everything else pretty much you're not going to have to touch on this setup. It will be good. The book now tells us, though, to go further with turning the engine back, and I'll go to that. We turn the engine backwards again until the cam sensor lines up, or the cam tooth lines up with the sensor. And we're using rising edge. This is coming around this way. So when the rising edge is just past, that's our trigger. And the key is with this is we don't want that to line up when the cam sensor is right over that missing tooth. It's close on this one, but we should be totally fine because we're using rising edge for trigger. If we aren't fine, the way I built this is I can just loosen off the distributor and give it a rotate to make this into a good spot for us, or we could actually pull the distributor and jump it one tooth. Either or, might have to do that in the end, but I think for the initial settings of where we are, I think we are set, and I'm going to carry on with other sensors. If you're not using a sequential setup, you wouldn't even need the cam sensor. You would just need the crank sensor with some kind of identifier of where number one top dead center is. You wouldn't have the options with the coils and so on, but with the sequential, that's really going to make it nice. And as well, doing the sequential injection with Megasquirt, if this thing is running and say we have a cam sensor failure, like there's something goes wrong with that part, well, when this thing started, the ECU is going to remember what phase it's in. So even if this thing has a failure, it's still going to be able to run, and if it by chance can still identify during cranking where this sensor is locating this cam sensor, it's going to continue to work and run. Hopefully none of that happens and this thing works seamlessly, but we will see. The wiring for the cam and crank sensor now on this, I have just in the book where these sensors are, it tells you like what kind of sensor you're going to be working with, or you have to decide what you're working with. It gives explanations on them. And cam and crank sensors, there's some important notes in here, and I'll show you that out under the hood. But this is the really quick little whatever dirty drawing for them. So we have the cam sensor, the crank sensor, and we have 12 volts going to these. If we have the option of feeding this type of sensor 12 volts, we want to. And just a quick note, depends on the sensor you use. Some of them you need a resistor on them. That's a pull-up resistor, but in this case, we're using sensors that we don't need it. They have them built in. So we're feeding the red wire from fuse 4, 12 volts. And then if you see here, we have both of the signal grounds tied together. So this actually goes to pin 18. I'll have to write that in here, of the ECU. And then on the cam sensor, we are going the black and white to yellow, and that's pin 26, and white and black to white on pin 6 of that. Now, if we look under the hood here, the wiring to these sensors, they're just generic wiring. And then on the other side of the plug, this is a shielded wire. There's 2 wires in it. And if you look in there, it's going to tell you in the manual which one to use and which one to not use. And both of these cam and crank sensors, I'm using the same type sensor. So that's what we're dealing with. And if you look at the ECU, there it is shielded wiring going to this. This one actually is going up to the speed sensor behind the dash, but it's the same style sensor. It's just hidden in that bunch of wires. You can kind of see the end of that shielded wire right there. This process of doing this car is a big process, and I'm trying to take step by step to hopefully help someone be motivated, whether it to just restore a car or go as far as doing ECU setup. And yeah, I'm gonna probably have more of that kind of stuff in the future because I deal a lot with EFI. And if you haven't seen the videos on making the cam and crank sensor, please check those out because that might make a lot more sense of what's actually going on with this stuff. And I really appreciate you taking the time. Please like, share, and subscribe.